Dinosaurs, the magnificent creatures that once ruled our planet, vanished from existence around 66 million years ago. This event, known as the Cretaceous Paleogene (KPG) extinction event, marked a profound turning point in Earth's history. It wiped out not only the dinosaurs, but also a vast array of other life forms, both on land and in the oceans. Understanding the cause of this extinction event is crucial for comprehending the history of life on Earth and the forces that have shaped our planet. The KPG extinction event was a global catastrophe that had a profound impact on the course of evolution. It marked the end of the Mesozoic era, often referred to as the Age of Reptiles, and ushered in the Cenozoic Era, the Age of Mammals. One of the most widely accepted explanations for the KPG extinction event is the impact of a massive asteroid or comet. This theory, first proposed in the 1980s, is supported by a wealth of geological evidence. At the KPG boundary, a thin layer of sediment found all over the world contains high levels of iridium, a rare element on Earth but abundant in asteroids. This iridium layer, often called the iridium anomaly, suggests that a massive asteroid, estimated to be about 6 miles, 10 kilometers wide, collided with Earth around 66 million years ago. The impact would have released an unimaginable amount of energy, equivalent to billions of atomic bombs, triggering widespread wildfires, tsunamis and earthquakes. The impact also ejected vast amounts of dust and debris into the atmosphere, blocking out sunlight and causing a global impact winter. Another prominent hypothesis attributes the KPG extinction event to massive volcanic eruptions that occurred in what is now India. These eruptions, which lasted for hundreds of thousands of years, formed the Deccan Traps, a vast volcanic province covering an area of over 500,000 square kilometers, 200,000 square miles. The Deccan Traps eruptions released enormous quantities of volcanic gases, including carbon dioxide, sulfur dioxide, and chlorine, into the atmosphere. These gases would have had a significant impact on Earth's climate and environment. Carbon dioxide is a greenhouse gas, and its release into the atmosphere would have contributed to global warming. Sulfur dioxide, on the other hand, forms sulfuric acid aerosols in the atmosphere, reflecting sunlight back into space and causing global cooling. The combined effects of these gases would have resulted in dramatic climate fluctuations, which could have disrupted ecosystems and led to widespread extinctions. Section 4, A Changing World, Climate Change and its Impact. Climate change, whether caused by volcanic eruptions, asteroid impacts or other factors, has long been recognized as a potential driver of mass extinctions. The fossil record reveals that Earth's climate has undergone significant fluctuations throughout its history, and these changes have often coincided with periods of the major evolutionary upheaval. In the late Cretaceous period leading up to the KPG extinction event, there is evidence of gradual climate change. Sediment layers from this time period indicate a long-term cooling trend which may have put stress on dinosaur populations. This cooling was likely caused by a variety of factors, including changes in Earth's orbit and volcanic activity. The gradual cooling may have made dinosaurs more susceptible to the catastrophic effects of the asteroid impact or the Deccan Traps eruptions. Section 5, From the Sun's Fury, the Solar Flare Hypothesis. A less widely accepted but still intriguing hypothesis suggests that the KPG extinction event may have been triggered by a massive solar flare. Solar flares are intense bursts of energy from the sun that release high levels of radiation. While most solar flares are relatively harmless, a sufficiently powerful flare could have devastating effects on Earth. A massive solar flare could strip away Earth's ozone layer, exposing life on the surface to lethal doses of ultraviolet radiation. While there is no direct evidence of a massive solar flare occurring around the time of the KPG extinction event, some scientists have suggested that it could explain certain aspects of the fossil record, such as the apparent selectivity of the extinction. However, the solar flare hypothesis remains highly speculative and requires further research. Section 6, Unraveling the Mystery, the Importance of Multiple Hypotheses. The extinction of the dinosaurs is a complex and multifaceted puzzle, and it is likely that multiple factors contributed to this catastrophic event. While the asteroid impact theory is widely accepted, it is essential to consider other hypotheses, such as volcanic activity, climate change, and solar flares, to gain a more complete understanding of this pivotal moment in Earth's history. Further research is needed to fully unravel the mystery of the dinosaur extinction and to determine the relative contributions of these different factors. By exploring multiple hypotheses, scientists can piece together a more accurate and nuanced picture of this ancient catastrophe and its implications for the evolution of life on our planet.